In this short video we are going to demonstrate how to use a 9640 to perform a flatness or frequency response calibration for an RF millivoltmeter. To perform this calibration traditionally you would need to use a power meter and power sensor as a calibration standard, such as we see here, with the signal being produced by a signal generator coming into a splitter sharing the signal between the power sensor and the RF millivoltmeter input. Now this involves some metrology to account for the splitter tracking and loss errors, and also to convert from what is probably a measurement on the power meter of power rather than voltage, unless you happen to be lucky enough to have a power meter that can respond in terms of voltage as well as power. However, in the case of the 9640, we will see that process is much simpler. We have a signal delivered directly to the input of the unit under test from the 9640 leveling head, much simpler connections, and we could also select the output of the 9640 to be directly displayed in terms of voltage. This RF millivoltmeter is specified to operate from a frequency of 10 kHz up to and above 1 GHz. So we're going to have a look at the frequency response relative to the frequency of 10 kHz. So first of all we will set a frequency of 10 kHz on the 9640, and we're going to calibrate the 100 millivolt range of the RF millivoltmeter. So I'm going to set my 9640 level in terms of millivolts. So I'm going to use the units facility to change into volts RMS and then select 100 millivolts. Turn the output on, wait for the meter to settle, and we notice there is a small error. Now I would like to measure the frequency response with respect to this point, so I need to just make a slight adjustment to the output until I read precisely the correct value of full scale, and I want to set that as a reference point for the frequency response. So I press the Set as Reference button, and the 9640 will remember that point as a reference in terms of level and frequency. So I can turn that off, and now I like to change my frequency up to 1 GHz. Wait for the reading to settle, and you notice we have an error. And we can make use of a feature of the 9640 to show us that error directly in terms of percentage of the UUT. If I press the error key, offset key, I can show that offset in terms of the UUT error. So I can get a direct reading of the UUT error in percent. And I'm going to make use of the scroll wheel and then the up-down keys to set exactly a full-scale reading. And now we can see exactly the error of the unit under test with no need to make any calculations or take into account any other sources of measurement error, because my 9640 is delivering the signal directly into the UUT input. Now we can go on and make some measurements at some other frequency points, and if I want to do that I might like to go quickly back to my reference point to check that nothing has drifted before I go on to make some measurements at some other different frequencies. And incidentally, we have an instrument here which is specified for frequencies down to 10 kHz, but the 9640 is ideal for other instruments with lower frequency ranges because its frequency range goes down to 1 MHz. So we can easily calibrate other RMS voltmeters, for example, RMS voltmeters with frequency responses well down into the audio frequency range, with its very wide frequency coverage from 1 millihertz up to 4 gigahertz. It's an ideal, simple and easy to use solution for the calibration of RF millivoltmeters.